This screencast introduces a new JavaScript library for adding internationalized text to web applications. Recently, I needed to add language translations to a web application. None of the existing approaches I saw satisfied my goals, which were to translate web application text to multiple languages, look up translations ahead of time to avoid incurring translation costs during every use of the web application, be very simple to add new translations and use them in the code, and be open source. So I wrote my own open source library called Web Translate. It is available in NPM at the URL on the screen. It provides a set of JavaScript functions and one command that is used to generate the translations. Web Translate is not specific to any web framework. It can be used with React, Vue, Angular, and any other web framework. Initial text must be specified in English. Translations for other languages are generated from that. I started with 6 primary goals. The first goal was to determine the required translations from 2 sources, literal strings in the code that uses the translations, and a separate JSON file. The rationale for the JSON file will be explained later. The second goal was to enable use of the 2 most popular translation services. These are the Google Cloud Translate API and the Yandex Translate service. The third goal was to enable easily generating new translations when support for new languages is required. The fourth goal was to allow generated translations to be overridden. This is important because translation services do not always generate the correct or desired translations for every application. The fifth goal was to support generating translations as a build step. This avoids incurring additional translation costs during each user session. Finally, the sixth goal was to support generating translations at runtime. While this incurs additional cost, it's necessary in some cases to handle translations for text that is not known until runtime. Both the Google and Yandex translation services require the use of an API key. The URLs on the screen provide information on how to obtain these. Using the Google Translation Service requires creation of a Google Cloud Platform or GCP project. The cost to use this service is $20 per million characters translated. Most web applications require fewer translations than this, so the cost will be quite low. The Yandex service has a free tier and a commercial tier. The free tier allows translation of 1 million characters per day, but not more than 10 million per month. This is sufficient for most web applications, especially when the translations are not performed at runtime. The commercial tier costs $15 per million characters. The cost per million goes down after 50 million characters have been translated. There are 4 steps required to prepare for using the Web Translate library. The first step is to install the library by entering npm install web-translate. The second step is to set the environment variable translate_engine to Google or Yandex. If this is not set, the default value of Yandex is used. This was chosen as the default because it has a free tier. The third step is to set the environment variable API key to the API key for the translation service to be used. The fourth step is to add the npm script shown on the screen to the package.json file for the application. This is used to generate translations. The application must provide a list of the languages to be supported. This is done by creating the file languages.json with content similar to what is shown on the screen. One place to obtain language codes is the Wikipedia link shown on the screen. The file languages.json must be accessible through an HTTP GET request at the domain of the web application. For example, if the application is available at http localhost:3000, then a GET request sent to that with /languages.json must return the content of this file. This is accomplished by placing the file in the same directory as index.html. Often this directory is named public. JavaScript files in the web application that need language translations should import the i18n function from the Web Translate library as shown on the screen. To obtain a translation for a given string of text in the currently selected language, call the i18n function passing the string. Later we'll describe how to set the current language. The I18N function can also be passed a key instead of the text to be translated. The key is used to look up the text to be translated in a JSON file shown on the next screen. Using keys instead of the text to be translated is useful for long phrases, sentences, or even paragraphs. This screen shows an example where the desired text is quite long. We can use the key string greet in the code instead of the text welcome to my wonderful web application. Keys must be defined in the file en.json that holds English translations. This file should have content similar to what is shown on the screen. It must be accessible in the same way as the languages.json file. Manually looking up translations and adding them to JSON files would be very tedious and time-consuming. WebTranslate does this for you. You simply enter npm run gen_tran and wait a few seconds. Of course, the time required is based on the number of source files that must be searched to find the required translations and the number of translations required. The next two screens describe this process. Step 1 is to get all the languages to be supported from the languages.json file. Step 2 is to find all the literal strings that are passed to the I18N function in all the source files under the source directory. Only files with the extensions JS, JSX, TS, TSX, and Vue are searched. Step 3 is to get all the English translations from the en.json file. Step 4 is the most involved. For each language to be supported, it does 4 things. First, it creates a map of translations for the current language, where the keys are the translation keys and the values are the translations to use. For example, if the language is Spanish, a key could be hello and the corresponding translation could be hola. This map is initially populated with any overrides for the language. These are used to override translations from the translation service. We'll talk more about overrides later. If there are no overrides for the current language, the translation map starts out empty. Second, it iterates through the translations in en.json. If any of these keys are not already present in the translation map, it gets their translation from the translation service and adds them to the translation map. Skipping keys that are already present allows overrides to take precedence. Third, it iterates through all the literal strings found in calls to I18N in the source files. If any are not already present in the translation map, it gets their translation from the translation service and adds them to the translation map. Fourth, it writes the translation map to a new translation file for the current language. The generated translation files should not be manually edited. Changes to them will be overwritten the next time the npm run gen_tran command is run. If the I18N function is passed a variable instead of a literal string, no translation will be provided. This is because it would be very difficult to trace the flow of the code and determine every possible value of the variable. When variables are needed, manually add English translations in the en.json file. These will be translated to all the supported languages when the npm run gen_tran command is run. The UI for a web application that uses WebTranslate can easily allow the user to select the language of the text that is rendered. There are 6 steps to do this. First, import 4 functions from the WebTranslate library as shown on the screen. Second, get the current language by calling the getLanguageCode function. Third, get a list of the supported languages by calling the getSupportedLanguages function. This will match what is found in the languages.json file. Fourth, render a drop-down list that contains an option for each of the supported languages and shows the current language is being selected. Fifth, when the user selects a different language, pass its language code to the setLanguage function. Finally, do something to cause the current page to re-render so new language translations will be displayed. Details on how to do this vary based on the web framework being used. For example, a React component could call this.forceUpdate. In some applications, there are parts that dynamically generate text that require translation. In these cases, the translate function can be used to perform runtime translations. This function takes 3 arguments: the from language code, the to language code, and the text to be translated. The example on the screen translates particular text from English to French. In order to use the translate function, the translate engine and API key environment variables must be set in the environment where the web server is running. Keep in mind that using this incurs charges for every user session. Avoid this when possible. Let's walk through a scenario of using WebTranslate. We can begin with the 3 files shown on the screen. Languages.json lists the languages we want to support. en.json contains the English value for a key we plan to pass to the i18n function. es.json contains the Spanish translation for the English text hello. To obtain translations for the word hello and the key --key in the code, we can pass those to the i18n function. If we have not yet run npm run gentran and the current language is English, we will get hello and my English key. If we change the current language to French, we will get hello and --key. This is because the file fr.json that will hold the French translations has not yet been generated. If we change the current language to Spanish, we will get hola and --key. This is because the file es.json that holds Spanish translations does exist, but does not define a translation for --key. If we now run npm run gentran, translations for French and Spanish will be generated. The file fr.json will be created, and the file es.json will be overwritten. If we change the current language to French, we will get bonjour and the French translation for my English key. If we change the current language to Spanish, we will get hola and the Spanish translation for my English key. We can add languages to be supported by editing languages.json. Here we add German and Russian. Then we need to run npm run gentran again to generate the files de.json and ru.json. Now translations for those languages are available. As a final example, we add a call to i18n to the code, passing it "Where is your pencil?" and run npm run gentran again. Now translations for that phrase are available in all the supported languages. Sometimes translation services return incorrect or undesirable translations for specific inputs. In these cases, we can tell WebTranslate to use manually entered translations. This is done by creating language-specific override files. These have names that begin with a language code and end with -override.json. For example, suppose we wanted the Spanish translation for hello to be hola instead of hola. To do this, we create the file es-override.json and add the content shown on the screen. Then we run npm run gentran again. That's all there is to it. Sometimes translation text needs to include text supplied by the web application. To do this, add placeholders that begin with $open curly brace, end with close curly brace, and contain a placeholder name. In the example on the screen, the placeholder names are name and day of week. Values for the placeholders are passed to the i18n function in a second argument that is an object where the keys are placeholder names and the values are their values. In the example here, the placeholder names are Mark and Tuesday. Translation text can include HTML tags. These are not translated. In the example on the screen, tags are included to italicize and bold parts of the translated text. WebTranslate provides the simplest approach to language translations in web applications that I've seen. Please post questions, suggestions for improvements, and any issues in the issue list at the URL on the screen. Thanks for watching. For details on OCI events and training, see the URLs on the screen.